Hey everyone, and welcome back to another launch video. So, last time we were able to introduce physical quantities, and we're still in section A under physical quantities, but last time we were able to introduce fundamental quantities and their units. So, I'll just write fundamental quantities and their units. And still under the realm of physical quantities, today we'll be doing unit conversion, and in our next video we will be looking at decimal places and significant figures. So again, just to kind of set the tone for what physical quantities are doing, within physics, we're trying to describe the world around us. We're trying to understand and relay information about what is happening to different objects, different systems in our world. And what physical quantities do, they kind of set the foundation for all of this because they help us to represent this information in a way that is understandable, right? It's our base quantities, it's the units that go with them, and they are the way that we are able to relay that information between each other, to the world, and so forth, right? So for today's lesson, let's dive right into unit conversion. So let's recall, our SI units, right? So we're diving into unit conversion. So our SI units, as we remember from last week's videos, are 7 quantities that are our fundamental way of representing different descriptors in our world, right? So if we have length, we want to use the meter, and that symbol is M. If we have mass, we want to use, If we have mass, we want to use the kilogram, and that symbol is kg. For now, I want you to remember the K right here, but we'll dive into that later. Then if we have, I keep making this mistake. If we have time, we want to remember that that would be the second, and that's represented by S. If we have current, that is the ampere, and that's represented by A. If we have temperature, that's the Kelvin, and that's represented by K. And if we have luminous intensity, which we don't really get much into at this level, but it's important to know, it's the candela, and that's represented by CD. And the amount of a substance is again our mole, and that's represented by MOL. So these are our SI units, right? But let's say on the exam, they don't want you to represent an answer as its SI unit. Like, let's say, for example, instead of giving the answer in meters, we wanted to represent it as a kilometer, right? Which I'm sure whether you drive or don't drive or taking the bus or whatever it is, you're going to have seen kilometers somewhere in some sign on the road, right? So let's say they wanted you to give the answer as a kilometer instead of a meter. And similarly, let's say instead of a kilogram, they wanted you to give the answer as a gram, or instead of seconds, they want you to give it as a millisecond, right? So in all of these cases, we're going to have to convert from one unit to another unit, right? For all of these examples. So for this as well, right? So how exactly do we do that, right? So I like to think of unit conversion in one of two ways, right? So the first way being that we go from, so let's look at this one first, that we go from something that has a prefix to something that has no prefix, which I call a non-prefix representation. And an example of that would be the one that is right here, which would be a kilogram to a gram. Or the second case, where we go from a non-prefix to a prefix, right? And in that case, that would be what we have right here, which would be like a meter to a kilometer, right? But let's take a second, because right here I've introduced this term prefix, right? But what does a prefix even mean? So when I say like, this kilometer, right, that we have right here, what does that K represent? What does that kilo represent? So let's take some time to talk about prefixes. All right, so prefixes, right? So the formal definition of a prefix is that it's a word, letter, or number that is placed before another, right? So we're placing it before something, right? And in your syllabus, there are a few common examples, some that you'll see more than others, of course, but let's take some time to look at these prefixes, look at the symbol that represents them, and what the numerical meaning of this might be, right? So let's leave our definition up here. So let's write prefix, let's write symbol, and then let's write meaning, right? So I'm going to list out a few examples that you might see very commonly. So let me change the size of my font temporarily. Okay, so kind of the much larger ones is tera, right? So tera you would place, like any prefix, in front of some other unit. So for example, like a terameter, a terasecond, a tera Kelvin if it's a really high temperature. But the symbol for tera is a capital T, and what tera represents is 10 to the 12. So if I have so let's make this our little example section. So let's say I have 1 terameter. What that is saying is that I have 1 times tera times a meter, right? And actually, let me write that more clearly. So if I have 1 terameter, what that is telling me is that I have 1 times a tera times a meter. And what my tera represents is 10 to the 12. And so 1 terameter means 10 to the 12 meters, right? So I won't do that for every single prefix, but that's the gist of what the prefix is doing for it. So similarly, if you have a giga, this is a capital G, and what it represents is 10 to the 9. If you have a mega, which is one that you will definitely see more often than tera and giga, you'll have a capital M, and it represents 10 to the 6th. Kilo, which is another common one, we had just mentioned it just above. It's a common K, and it represents 10 to the 3. Deca, which you won't necessarily see as often, but just as an important note, it's represented by DA, common D, common A, and it means 10 to the 1. Centi, which you will definitely see on the exam, is a common C, and it means 10 to the minus 2. Milli, which is a common M, you'll also definitely see this one, it's 10 to the minus 3. Micro, another kind of definite, especially when we get to the later section of the syllabus, is a Greek symbol mu. So it's kind of like a fancy M or a fancy U if you see it that way. And it means 10 to the minus 6. Nano, which you probably will see in the later sections on like physics of the atom and things like that. It's a common N and it means 10 to the minus 9. And finally, we have the pico, which is a common P and it means 10 to the minus 12, right? Okay, so I know I just said a lot. So again, just to remind you guys that what we're doing here is that we are prefixing our units, right? So if we look over here in this section, what we've done is that we've taken a regular SI unit, which is our meter, and we've put a prefix in front of it, so creating a different representation of that value. Because for example, it would be difficult to always say like, oh, 10 to the 12 meters, 10 to the 12 meters. No, you can just say a terameter, right? And it gives you that meaning without having to write it out all the time. Similarly with kilograms, similar with centimeters, sometimes the best way to represent a value isn't always in its SI units, because it might be a very large value, like a terameter, for example, or a very small value, like a picometer. And you just want to be able to write that symbolically, you want to write that numerically without always referring to just the meter or the gram or the second or whatever it is by itself, right? Okay, so again, let's look at an example of these prefixes in action. So let me just section this off, and let's say that we're calling this our prefixes in action, right? So let's say we wanted to look at 1 kilogram, but we wanted to represent it as a gram. From our table, we know that kilo means 10 to the 3, and so what we would do is say that 1 kilogram is equal to 1 times the representation of kilo that we're seeing right here times a gram, right? And what that means is it would be 1 times what we saw up here, which is 10 to the 3, times a gram. So kind of a simpler way of writing it is 10 to the 3 grams, or because it's not that long, just 1,000 grams. So 1 kilogram is equal to 1,000 grams. So this is an example of our prefixes in action, and what they're doing is saving us time, because instead of having to write out like 1,000 grams, or if it's 10,000 grams or 50,000 grams or whatever it is every single time, we can just write our K and we're able to communicate the same thing. Just to go over one more example, let's say we have 1 centimeter and we want to represent that in meters. We know that a centimeter is equal to, or know that the prefix centi that we see right here is 10 to the minus 2, and since we're prefixing the meter, it would just mean 10 to the minus 2 meters. Or if you want to write it out, that's no problem. It would just be 0.01 meters. All right, so these are just 2 examples of our prefixes in action and making life a little bit simpler for us, right? So those are just 2 examples of us converting units. But, let's get back to what we said earlier, which is that with prefixes, you can do kind of one of 2 things. So in the first case, you can go from a prefix to a non-prefix, and that's exactly what we just did up here. So let's say we're going from a kilogram to a gram, or a kilometer to a meter or a megasecond to a second. In each of these cases, we're going from something that has a unit that has a prefix in front of it to one that has no prefix, right? And this is kind of the simpler hand of unit conversion, because in all of these cases, what we can do is just take the prefix as its literal meaning. So in this case, kilo being 10 to the 3, and so that would just be what we put in front of the grams. Kilo here still being 10 to the 3 is what we would just put in front of the meters. Mega being, let's remind ourselves, is 10 to the 6th. And so again, we would just put that in front of our unit. So I would say that we're pretty good on going from prefix to non-prefix, right? A kind of harder, at least for me, in terms of when I was just starting to learn this, is going from non-prefix to prefix, right? So let's say, for example, we want to go from a meter to a kilometer, or if we wanted to go from a gram to a kilogram, or, like we have up there, say we wanted to go from a second to a megasecond. So in these cases, it's a little bit more tricky, because in this case, we don't have our prefix in front to just simply, multiply and give us the representation that we want. And so how I like to think of this is two ways. So I'll explain the kind of more straightforward way first, and then another kind of trick that I do to remember. So let's say we wanted to go from meters to kilometers. So let's look at example 1. Let's say we wanted to go from meters to kilometers, right? So we know that 1 meter would be equal to some amount of kilometers, right? And let's recall that with prefixes, what we're doing is multiplying out our variables, right? So in this case, we want our left-hand side to be equal to our right-hand side numerically, right? We want to find 1 meter to represent a certain amount of kilometers, right? So right now, what is happening is that we have 1 meter is equal to some amount of kilo, which we know, so let's put our little multiplication symbol here, which we know is 10 to the 3. We're multiplying again. The asterisk here I've used as a multiplication symbol. Meters, right? So we have 1 meter is equal to some amount of kilometers, right? And so if we want our left-hand side to be equal to our right-hand side, we have to put some factor here that is going to allow this 10 to the 3 to cancel, so that I have my meters over here, fine, right? So what I end up doing is, and let me change color just to make it as clear as possible, is dividing by 10 to the 3. Now, why do I do that? For precisely the reason that I'll be able to cancel this, and I'll end up with my left-hand side being equal to my right-hand side. But that's not what we asked, right? What we wanted to know was how many kilometers are in a meter, right? And so if we go back to our original statement, we have 1 meter is equal to some amount of kilometers. What we did here was find our conversion factor that will allow our statement to be true. And in this case, it ended up being 1 over 10 to the 3. And we can think of this as kind of two ways. So 1 over 10 to the 3, you can think of it as 10 to the minus 3, or you could think of it as 1 over 1,000. You can think of it as 0.001. Whatever it is, however you want to call it, let's remember that this is our conversion factor. 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 And all of these are equal, right? And what our conversion factor means is that what we've taken is 1 meter, and we've said that it is equal to, and let's insert our conversion factor here. It's equal to, I'm going to write it differently this time, 10 to the minus 3 kilometers, right? And that is kind of the more intuitive way, at least for me, how I think about it, is that I'm looking for ways to have these units cancel out each other so that I can have my units here be equal to the same thing. But it's important to keep track of these steps, because as you saw here, we started here with like 1 meter is equal to some amount of kilometers. We took what a kilometer meant, but we've still left our blank space for what we're trying to find it to be. Then we want to find some way to cancel it. So we have divided by 10 to the 3 here so that these two cancel. And that's how we ended up with our conversion factor, the thing that we had to take and divide by. So I'm going to do one more example just to make that as clear as possible. So let's say we had, in this case, let's make it a little trickier. Let's say we had 25 meters and we want to find how many kilometers it is equal to. So again, what's our first step, right? We look at what this right-hand statement is saying to us, which is that 25 meters is equal to some amount of 10 to the 3 meters, because that's what kilo means, right? But we want to find something that we can insert in this little box right here to make these two statements equal to each other. So in our second step, we find what that number is. So before, we were just converting from 1 meter to kilometers. This time we're doing 25. So if we want to take some value that we're going to have cancel out here, it's going to be a little bit trickier. So let's remember that 10 to the 3 is 1,000, just to make that more explicit. And we're going to have to divide, in this case, or let's just call it multiplication, by 25 over 1,000, right? Because our thousands are going to cancel here, and we end up with 25 meters, similar to 25 meters here. And we have our left-hand side equal to our right-hand side. And so what this told us is that 25 meters is equal to 25 divided by 1,000 kilometers. And we can write that more simply as 0.025 kilometers. So that's one way to think about it. How I kind of have trained my mind to do it is that if I'm going from non-prefix to prefix, so again, let's say I have my grams to kilograms. So if I have 1 gram is equal to some amount of kilogram, what I do is just take the opposite, so the opposite of what this prefix on the right hand side means. So in this case, kilogram would be 10 to the 3, the opposite would be 10 to the minus 3, and that is my answer. So it would be 1 gram would be equal to 10 to the minus 3 kilograms. Always remember to write back your kilograms, because it's these in tandem with each other that allow us to have our accurate representation. So that was kind of fast, just to show you another example. Let's say we had 25 grams is equal to some amount of kilograms. I know that the opposite of kilograms would be not 10 to the 3, because that's what kilograms means. It would be 10 to the minus 3. And so I would have 25 grams is equal to 25 times 10 to the minus 3 kilograms. And that would give me my 25 grams is equal to 0.025 0.025 kilograms. Okay, so just to give a quick summary of what we just did, we're still in the realm of physical quantities. Last time we were able to look at quantities and their units. Today we looked at unit conversion. And again, what unit conversion is doing is it's taking some unit that we have. So let's say that's meters, and maybe we're converting it to kilometers. Maybe we're taking kilograms and converting it to grams. Maybe we're taking seconds and converting it to milliseconds. This does not change the fact that our SI units are still these things, right? All this is doing is just allowing us to look at a different way of representing our units. We can do this by using what we call our prefixes, so our teras, our gigas, our kilo, centi, all of these examples, because they have some numerical representation that allows us to represent things how we want to, right? And here's some examples that we went over of these prefixes in action. Either converting from prefix to non-prefix or non-prefix to prefix. And, a more complicated version you might see is like if they say how many units, like let's say we have 25 kilograms is equal to however many megagrams. You'd still end up using these two principles, because what you could do is go from prefix to non-prefix, as in your gram. So you can convert from prefix to non-prefix and then go from non-prefix to prefix, just as a way of getting it from prefix to prefix. And these were some examples that we went over. I would recommend, watching this video maybe a couple times until it's cemented, but we'll also post some practice questions for you on the website. So thanks for watching, and I look forward to jumping into decimal places and significant figures next week.